You know, when you picture a vast desert, you probably just see endless hills of sand, right? But what if I told you that those massive, sculpted dunes are actually behaving like living, breathing creatures? It sounds like something out of science fiction, but the physics behind it is absolutely incredible. So let's dig in and explore how this is even possible. And that's not just some fancy, poetic language. This is what they literally do. Dunes are in constant motion. They travel across entire landscapes. They can break apart to create new baby dunes. They expand and contract. And they react to their surroundings in a way that's, well, uncannily lifelike. And that's the big question, isn't it? How on earth does a collection of tiny, inert grains of rock organize itself into a system that mimics the behaviors of life? Well, the answer starts at the absolute smallest scale. To really get how a dune can be alive, we first have to understand the very strange nature of sand itself. See, sand has this kind of secret identity. When it's just sitting there, it's a solid. You can build a sandcastle with it, no problem. But the moment you add energy, in this case wind, it completely transforms. It starts to flow, almost like a liquid. This dual nature, this ability to be both a solid and a fluid, that's the key to everything. The process that kicks this whole thing off has a cool name, saltation. It's this beautiful, cascading chain reaction. A gust of wind lifts a few grains of sand, they fly for a little bit, and then they crash back down, knocking other grains into the air. It's this incredible domino effect, a coordinated dance of billions of individual grains that makes the entire dune look like it's moving as one. Okay, so we've got this chaotic dance of individual grains. But how does that create something as huge and organized as a dune? Well, that's our next stop. I want you to picture a dune breathing. Seriously, the wind blows grains up the long, gentle slope. That's the inhale. The grains pile up right at the sharp peak until gravity just takes over and whoosh, they cascade down the other steep side in a tiny avalanche. That's the exhale. And with every single one of those breaths, the entire dune inches forward. And this process, this breathing, it isn't random at all. Dunes are incredibly responsive. If the wind changes direction, the dune will slowly, patiently pivot to face it. If it rains, the moisture acts like glue, holding the grains together, and the dune basically holds its breath, waiting. This isn't just mindless movement, it's adaptation. This ability to adapt leads to this stunning diversity of forms. It's almost like different species in an ecosystem. You've got the crescent-shaped barchan dunes that really look like they're galloping across the desert. There are these long linear dunes that look like the ribcage of some colossal buried beast. And then you have star dunes, which form where the wind is all over the place, so they reach out with arms in every direction at once. But here's where it gets even weirder. Dunes aren't loners. They have a surprisingly complex social life, full of what looks like competition and cooperation. So let's take a look at how these giant sand creatures actually interact with each other. Okay, one of the most mind-bending things happens when dunes collide. When a small, fast-moving dune catches up to a much bigger one, it looks for all the world like it's being eaten, just gobbled up. But it's all an illusion. Because of the physics of sand and airflow, the smaller dune is able to effectively transfer its mass through the larger one, and then it just pops out on the other side, totally intact. It's wild. The life analogies just keep getting stronger, don't they? Dunes grow when there's plenty of wind and sand. They can even reproduce by splitting off a piece, a process called calving, which becomes a new independent dune. And they travel in herds, vast dune trains that migrate across the desert together in this incredible synchronized harmony. Now you might be thinking, okay, this is amazing, but it's a special feature of our planet, right? Well, it turns out this phenomenon is way more universal than you'd think. So I want you to just focus on this number, 3. In our solar system, we know of at least 3 different worlds where these living landscapes exist. And those 3 worlds, they are Earth, Mars, and Saturn's giant moon, Titan. Now, think about that. Despite enormous differences in gravity and atmosphere, and even in what the sand is made of, the same fundamental physics creates these migrating, interacting, lifelike forms. The rules are truly universal. So if this is happening on other worlds, built from totally different materials under completely different skies, what's the deep underlying principle that connects them all? What's the secret sauce?
The big idea is something called self-organization. It's a process where you get these complex, ordered patterns that just emerge from simple, chaotic interactions between individual parts. Think of a flock of birds turning in perfect unison, or a termite mound built without any blueprint. Nobody's in charge, yet this coherent, seemingly intelligent structure just appears. For dunes, it's billions of chaotic grain movements, giving rise to a stable, migrating creature.
So let's circle all the way back. Are dunes alive? Well, no, not biologically. But, and this is the important part, they are governed by the same deep principles of complexity that shape life itself. They're playing by the same rulebook, showing up in everything from galaxies to ecosystems. It's really this powerful reminder that the universe is just full of these systems that blur the line between the living and the non-living. It's like poetry written in the language of physics. And maybe that's the absolute best way to think about it. A sand dune is a physical sculpture of energy and time. In its slow, relentless journey across the land, it reveals the invisible breath of the planet, the wind, and turns a simple pile of inert sand into this dynamic, migrating, and truly awesome spectacle. It really challenges us to look around and ask, what other hidden life is just waiting for us to discover? Not in biology, but in the fundamental laws of the universe itself.